In this example, we are asked to find the second derivative of some functions, so that's what we're going to practice. We're going to practice these rules, and actually this is good because it gives us more practice. And so the first one, we're asked to find the second derivative. We're given y equals 2.5 q squared minus 0.75 q plus 9.23. So this one is a quadratic, but with slightly messier numbers, which is actually going to happen a lot more often in applied problems. And the rules of this, and so we want to find y double prime. And in order to do that, we first have to find the first derivative. So we use our shortcuts to find that y prime, the first derivative, using the power rule on this term, we'd have 2.5 times 2, q to the first. I guess I'll write it like that, even though we don't normally write it, because we're going to do some simplification as we go on. And then minus, and then the derivative of this. And this is just 0.75 times q, excuse me, and the derivative of that will be 0.75, and it's subtracted. And then here we just have a constant. And the derivative of a constant is just 0. And one of the reasons we could think about this is this adding 9.23 to this, all it does is shift everything up. It doesn't change the shape of the graph. So the derivative is not affected by the fact that we added, or even if we had subtracted 9.23. So that is plus 0. So I'll write that to see where that went. So I'm going to simplify that a little bit. 2.5 times 2 is 5. 5q minus 0.75. Now we're asked to find the second derivative. And the second derivative is just the derivative of the first derivative. So we just use our derivative rules, again, on this. This is actually a linear function. So the derivative of this line is just going to be the slope, which is 5. The second example is we are again asked to find the derivative, and we're given our cost function, c of q is q times q squared plus q to the negative 2. Now for this one, what we'll want to do is we will want to simplify first. We have not talked about what happens when you multiply things out, what our rules are. So we need to simplify first. Similar to when we would like to rewrite things in exponential form, do any algebra you can to make finding the derivatives easier. And when we multiply through, we add exponents, so we're going to have q cubed and then plus q to the negative 1 when we multiply that through. Then, when we take the derivative, using our power rule, we're going to bring down the exponent, 3q squared. And then here we're going to bring down the exponent. So we're going to get a minus q to the negative 2 when we subtract 1. Now we're asked to find the second derivative. And using our power rule on each of these again, we're going to have 6q plus 2q to negative 3. Some scratch work we might write in between. And don't be afraid to write this. We'd have 3 times 2q to the 1 minus negative 2q to the negative 2 minus 1. And that's how we got the 6q plus 2q to the negative 3.